In this video, let us try to solve few more trigonometric identities. Let us solve these three problems. Please pause the video and try it out yourself. Then once you have solved all the problems, you can play the video and check if the solution you used is similar or something better in the video. So please pause the video and give it a try. Now let's solve the first problem. Here we have to prove that 1 plus secant A divided by secant A is equal to sine square A divided by 1 minus cos A. So how can we approach this problem? So here we observe that secant has changed to sine. So there is a chance that we have to apply trigonometric identities here, which is cos square A plus sine square A is equal to 1. So let us try it out. Let's take the right hand side. Secant A can be written as 1 plus 1 by cos A divided by 1 by cos A. So this will give us the value, if we simplify, cos A plus 1 divided by cos A divided by 1 by cos A. We can cancel the denominators. So we will end up with 1 plus cos A. Now, if it is only 1 plus cos A, there is nothing further that can be achieved. So what we can do is, just to arrive at cos square A plus sine square A is equal to 1, we have to make sure there is a square in this function. And to introduce that, what we can do is, we can multiply and divide this by 1 minus cos A. So the value of the function does not change because we are multiplying and dividing it. So it's basically a multiplication with 1. So now this is of the format, if you observe the numerator, this is of the format A plus B, A minus B. Now what we can apply is 1 minus cos square A divided by 1 minus cos A. And 1 minus cos square A is nothing but sine square A. So the answer will be sine square A by 1 minus cos A. Now let us solve the second problem. Here we have to prove that cos A minus sine A plus 1 divided by cos A plus sine A minus 1 is equal to cosecant A plus cot A. So if you observe that, on the right hand side we need cot and cosecant. Cosecant is nothing but 1 by sine, that is when sine is in the denominator. So to get sine in the denominator, what we can do is, let us divide the numerator and denominator by sine. So this will be cos A by sine A minus sine A by sine A plus 1 by sine A divided by cos A by sine A plus sine A by sine A minus 1 by sine A. So now let's solve for this. Cos A by sine A is cot A minus 1 plus cosecant of A divided by, now cos A by sine A again is cot A plus 1 minus cosecant of A. Now this can be further written as, so always try to get it in the format of A and B, so that some equation like A minus B or A square minus B square, all these things can be applied. So what we can do is cot A minus 1 minus cosecant A. I just took the negative as a common value. Then cot A plus 1 minus cosecant A. So now we have a format of A minus B and A plus B. Now what we can do is, let's multiply and divide this equation by A minus B. So what we will have here is, if we multiply it with whatever is in the numerator, which is a minus b, we will get cot a minus 1 minus cosecant a times cot a minus 1 minus cosecant a. We're just multiplying it, divided by, what would this be? A plus b times a minus b. So this will be cot a plus 1 minus cosecant a times cot a minus 1 minus cosecant a. Correct? Now the numerator would be a whole square, which is cot a minus 1 minus cosecant a, the whole square, divided by cot square a minus 1 minus cosecant a, the whole square. So how do we further solve this? Now let's expand this. This is of the format of a minus b the whole square. Correct? And this is a square minus b square. However, b square is 1 minus cosecant a the whole square. So let's expand this, apply the equation. So the numerator will be cot square a plus 1 minus cosecant a the whole square minus 2 times cot a times 1 minus cosecant a. So basically this entire part is b and this entire part is a. So that's how we applied it. Now the denominator would be cot square a minus 1 plus cosecant square a minus 2 cosecant a. I'm sorry about that. It's not cosecant square a, it's cosecant a. Okay. Now let's further solve this equation. Now it's just solving the equations and trying to find if we can apply a trigonometric identity. So let's apply a minus b the whole square again to this part. So cot square a plus 1 plus cosecant square a minus 2 cosecant a minus 2 cot a plus 2 cot a cosecant a. I just multiplied this cot a with the next value, divided by, what would be the denominator? It would be cot square a, let's solve for this negative sign, minus 1 minus cosecant square a minus of minus would be plus 2 cosecant a. Correct? Now what we can write is 1 plus cot square a is nothing but cosecant square a. So this would be cosecant square a plus cosecant square a, which is nothing but 2 times cosecant square a, then plus, let's rearrange this, 2 cot a cosecant a minus 2 cot a minus 2 cosecant a, divided by, now let's check the denominator if we can solve for anything. So we have cot square a minus cosecant square a, which is nothing but minus 1, correct? So this would be minus 1, which is an existing minus 1, in the plus 2 cosecant a. Now let's solve the above equation. So what can be considered as a common value here? 2 times cosecant a in the numerator. So 2 times cosecant a would be the common value. So cosecant a plus cot A. Then minus 2 would be common in this. So this would be cot A minus cosecant A, correct? Divided by 2 cosecant A minus 2. Now what we can do is, what are the things that are cancelable here? So 2 cosecant A minus 2, and just a second, if we take 2 minus 2 as common here, this would be plus, correct? So basically this is a common field now. So what we can do is we can take that as common, cot A plus cosecant A times 2 cosecant A minus 2 divided by 2 cosecant A minus 2. This cancels out. So now we have cot A plus cosecant A. So this is how we can achieve at the right hand side of the equation. This was a bit complex, but we will solve more complex problems so that it will be helpful for the students. Please keep in mind that the correction that we did was when we commoned out minus 2 from these two fields, the value would be plus. So that is one thing I missed. Please make a note of it when you're solving. I'll see you in the next videos. Thank you for watching. Please subscribe to the channel and share it with your friends. Thank you. In this video, we have to prove that square root of 1 plus sin A divided by 1 minus sin A is equal to secant A plus tan A. So how can we achieve this? So let's observe the result we want to achieve. We need secant A and tan A. So secant A is nothing but 1 divided by cos A. So 1 divided by secant A is nothing but 1 by cos A, correct? And tan A also has cos in the denominator, which is sin A by cos A. So to approach this, we should have cos in the denominator. So how can we have cos in the denominator? We need to get identity cos square A plus sin square A equal to 1. We need to apply this. So basically cos square A is equal to 1 minus sin square A, correct? Now how do we convert this denominator to 1 minus sin square A? So let us multiply and divide by 1 plus sin A. So the numerator will be 1 plus sin A times 1 plus sin A, and the denominator will be 1 minus sin square A. Now because this is 1 plus sin A the whole square, let us solve it. We will have 1 plus sin A the whole square, and the denominator is cos square A. We found that out here because of the identity. Now if we solve for the square root, we will have 1 plus sin A divided by cos A, which is nothing but secant A plus tan A. So this is how we can identify what solution to apply and arrive at the result. So please share the video with other students so that it's helpful to them. Thank you for watching. I'll see you in the next video.